Example 1 for using prime factorization to find GCF. If you forgot what GCF stood for, it means greatest common factor. And greatest common factor means the largest number that could divide each of your terms. So with example 1 here, let's say we had something like 20x cubed y, and then we'll have a second term, and maybe we'll have something like 36xy squared. So we have to decompose each of these numbers. We want to break them down into their prime values. So I look at the 20, and I recognize that 2 divides 20. 2 goes into 20 10 times, and then I can break the 10 down into a 2 and 5. I cannot stress enough to make sure that you have prime numbers down here. You're trying to decompose it into nothing but prime numbers. That's why it's called prime factorization. Several times when we go over this, I'll see that kids will try to divide by 4 or whatever, and they're like, oh, why can't I do that? Because prime numbers are the only values that are allowed to be on the outside here. And so as I decompose this, I get 2 times 2 times 5, x, y. And then I move to this 36, and I'm going to do a similar thing. I'm going to divide by 2, takes me to 18, divide by 2, takes me to 9. As I mentioned in a previous video, when you get to a square number, that should be an immediate breakdown then. You know that's 3 times 3, okay? So my prime factorization here would be 2 times 2 times 3 times 3, x, y. And the idea with a prime factorization is that you want to see the greatest common factor. What do these two things have in common? What are their common factors? And so as I look here, I'm just going to underline everything that they have in common. I see 2 2s. I see a 5, but there's no 5 here. I see 3s, but there's no 3s there, so those aren't common. I go to the variables. They each have one x in common, so I can underline an x, and in a similar way I can underline a y. At this point, I can identify the GCF by multiplying what was underlined in any one term, because again, it's what they have in common. So when I look here, I know what's been underlined here has been underlined there. So you only have to look at one of these things and say, all right, if I multiply this out, what do I have? 2 times 2 is 4xy. So the GCF is 4xy. That's what the two terms have in common. Let's do a second example. And let's say something like 65 ABC and 30 XYZ. I want to break down each of these values. So again, I have my 65 ABC. I look at the 65. I can divide by 5. Takes me to 13. So my prime factorization would be 5 times 13 A, B, C. In a similar way, I can break the 30 down. 5 goes into 30 6 times. 6 has to be broken down as 2 times 3. So I would list this from least to greatest, and I would say 2 times 3 times 5, x, y, z. Now as I look at each of the prime factorizations, I want to underline what they have in common. So I look here, I see a 5, and then over here is a 5. And then in terms of the 13, there's no 13 here. The variables, a, b, c, x, y, z, there's nothing that they have in common. And so the only thing I could portray as a greatest common factor would be the number 5. They each have a 5 to offer. Again, you look at those individually. I have an underlined 5 here, an underlined 5 there, so the GCF is 5. And let me do a real quick example 3 on this. What happens if you have, let's say you have 2 prime numbers. Let's say you had 3, and we'll throw an x on there, and then you had like a 5 and a y. The GCF of that, take a wild guess, it's 1. And the reason why it's 1 is because remember the definition of prime numbers. Prime numbers are numbers that are only divisible by themselves and 1, which means that every number, no matter what you write down, every number, I guarantee the smallest GCF would be 1. You have to be able to list something. And so in this case, when you look at that, you say, well, what made up 3? 1 times 3. What made up 5? 1 times 5. And so the GCF guaranteed would be a 1. Now that's like your default answer. As we go back through these first two examples, here, once you underline these other values, values other than 1, then obviously you're going to use those, or in some cases multiply them to get your answer. Here we had just the 5 underlined, so I'm going to use that. What I'm saying is, if you do not underline anything, if they don't have anything in common, you can always go to the default answer of 1. I guarantee it has a GCF of 1.